Well, today, class, we want to learn about the idea of solving absolute value inequalities. And in order for us to be able to do that, we need to understand what an absolute value inequality is. And it's an inequality that has one of the following forms. So we could have the absolute value of ax plus b is greater than c, or the absolute value of ax plus b is greater than or equal to c, or the absolute value of ax plus b is less than c, or the absolute value of ax plus b is less than or equal to c. So how do we solve one? Well, remember, what we want to do is when we're solving any type of inequality, we're trying to find values that I can put in place of x that would make this inequality true. So when I look at this case, I have the absolute value of ax plus b is less than c. Okay, so I want to find values that I can put in place of x that would make this value less than c. Okay? So in order to do that, we want to make an and inequality. So what we do is we take negative c, whatever is by itself on the other side of the inequality, is less than ax plus b, which is less than c. Now, there's another way we can look at it. So in this case, I have an inequality that's greater than c. Okay? So it's greater than c. So I want to find values that I can put in place of x that would make this absolute value greater than c, which means that I have to set ax plus b less than c, or ax plus b is greater than negative c. So what happens here is when I look at these inequalities, this tells me what type of compound inequality I'm going to get. This is a less than symbol, which means that I have an and compound inequality. And right over here, I have a greater than symbol, so that means it's going to be an or statement. So let's try to actually solve some inequalities. So when I look at this, it's the absolute value of x is greater than 5. So I know that I have an or inequality. And what I know is that x needs to be greater than positive 5, or x is less than negative 5. So x is always going to be smaller than the negative of this. So whatever's inside this inequality will always be less than the opposite of this number right here. But whatever's inside this inequality will always be greater than 5 when it's an or statement. Let's look at another one. So in this case, I have a less than symbol. Okay? So it's going to be a compound inequality in which what's in the middle of the absolute value symbols is going to be in the middle of the inequalities. And it's going to be less than or equal to 7, but it's going to be greater, x is going to be larger than the negative form of the answer. So it's going to be negative 7 is less than or equal to x, which is less than or equal to 7. So that means that any value that's between here will make this inequality true. So for example, a number that's in between is 0. So if I put 0 in place of x and I take the absolute value of 0, it should be smaller than 7. Well, yeah, 0 is smaller than or equal to 7. If I look at this previous one, so any value that's larger than negative, or any value smaller than negative 5 will make this inequality true. So for example, if I choose like negative 7, and if I do the absolute value of negative 7, it will be larger than 5. Well, yeah, 7 is larger than 5. That's true. Anything larger than 5 will also make the inequality true. So if I choose 6 and I do the absolute value of 6, it should be larger than 5. Well, yeah, 6 is larger than 5. So this is just doing a check step just to see, all right, are these inequalities true? So let's actually look at some that have something other than x inside the absolute value symbol. So this is a less than inequality. Okay, so that means that whatever's in between the absolute value symbols is going to be in the middle. X plus 6 is going to be in the middle of two symbols. It's going to be less than 1, but it's going to be larger than negative 1. Okay, so it's going to be in between the negative form of the what's on the other side of the inequality and the positive form. And all we're doing is just solving for x. So I have negative 7 is less than x, which is less than negative 5. And that's true. So that means that if I choose any value that's between -7 and -5, it will make the inequality true. So that means really I only have one answer, which is -6. If I plug -6 in place of x, and I do the absolute value of -6 is less than 1, I get 0 is less than 1, and that's true. Let's look at one more. In this case, I have a greater than symbol. So what I know is that x is going to be larger than the positive form of that. So I know it's going to be x minus 3 is going to be greater than 12. Or I know that x minus 3 is going to be smaller than the negative form of the answer. So that means I'm just going to add 3 to both sides, in both cases. So we have x is greater than 15, or x is smaller than -9. So if I choose any number that's larger than 15, it will make the inequality true. So like, for example, if I choose 17, 17 is larger than 15. So if I do the absolute value of 17 minus 13, or 17 minus 3, it should be larger than 12. Well, 14 is larger than 12. That's true. If I choose any value that's smaller than -9, it will make the inequality true. So if I choose -10, if I do -10 minus 3, that will be larger than 12. So I have the absolute value of -13 is 13, which is larger than 12. So that works out. Yep, that works out. So you guys have a couple examples, 4 examples to do. If you guys can do those for me, we'll talk about them tomorrow.